Today I'm going to go over Module 4, Chapter 6, Fractions and Rational Numbers. In this module, we learned about different fractions and how they're represented. So for this question, where it says write 4 sets of fractions having 3 fractions in each set, I'm going to go over the hexagon. You have a hexagon, a trapezoid, a rhombus, and a triangle. So in order to make a hexagon with the trapezoids, you would see that it takes 2 trapezoids to make a hexagon. Well, it gives you 1, so you'd have 1 out of 2 as your fraction, which is a half. When it comes to the triangles, you would take, as represented right here, there's only one triangle. So you have one that's given, but it takes 6 to actually make the hexagon. So your fraction would be 1/6. And with the rhombus, you would take 3 rhombi in order to make one hexagon. So it gives you 1, and then you take 1, 2, 3. There's 4 of them on here, but as you can see, it only takes half on the sides, so 2 halves equal 1. So you'd have 1, full 1, 2, and 3. You can do that with the trapezoid, with the other shapes, the rhombus, and also the triangles. Now, this question is, a man bought a length of rope at the hardware store. He used 1/3 of the rope to make a bow painter, and he used the 1/4 of the remaining piece to tie up the carpet. He has 36 feet of rope left. So to show this problem pictorially, you start off with a piece of rope. Well, you already know he used 1/3 of the rope to make a bow painter, and then he used 1/4 of it to tie up the remaining carpet. So you have 36 feet of rope left. Now what you would do is you would divide that up into equal parts, and there's 4 parts. So what I did was 36 divided by 4 equals 9, and then you go ahead and make the other parts even as well over here. So you have 1, 2, 3, 4, 5, 6, 7 sections of 9 feet of rope. So 9 times 7 is equal to 63. So he originally bought 63 feet of rope for his project. Now, we're representing fractions with strip models. You have the other strip models that you can see on the screen. How I did those is you start off with A is 1/3 plus 1/2. So you have a fraction strip that is in thirds, and you have a fraction strip that's cut in half. So to represent 1/3, you would go ahead and shade in one portion of it. So that's 1/3, and then you would shade in a half. So what you're trying to figure out is what 1/3 plus 1/2 is. So you see right here, I put a fraction strip that is cut into 6. So you have 1, 2, 3, 4, 5, 6 of the fraction strip that is covered. So 1/3 plus 1/2 is going to equal 5/6. As you can see, you can do that with any of these fractions, and they pretty much come up together. You can also show this in a number line. So my number line goes from 0 to 1, and you have 1/3. So 1, 2, 3 gives you 1/3 plus 1/2. So you do 1/2, and your answer is still going to come up to, sorry, I messed that up, to 1, 2, 3, 4, 5, 6. So your answer is 5/6. On the subtraction one, you start off with 3/4 minus 1/3. Well, in order to subtract, you would have to have the same denominator. Well, 4 and 3 are not the same denominator, so you would come up with the closest one, which is 12. So as you see in this number line, there are 12 spaces from 0 to 1. So you would go 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths, because 3/4 when you make it into 12. You multiply 4 by 3 and to get 12. So 3 times 3 is 9. So you went over 9/12. But you're also subtracting. So the 1/3 is going to turn into, you put 12. 3 times 4 is 12. So 4 times 1 is 4. So you'd have 9 minus 4. And it would come up to 5/12. So 1, 2, 3, 4/12. But the equation is equal to 5/12, which is where it ends right here. Now, you can also show fractions using a fraction circle diagram. On 3 times 1/5, you know that you have 1/5 of the circle shaded out, but you have it 3 times. So 1/5 plus 1/5 plus 1/5 is going to equal 3/5. Same as 3 times 2/4. You have 2/4 of it shaded. And so 2/4 plus 2/4 plus 2/4 equals 6/4. Also, again, you can show these in number line. So this first one is 3 times 1/5. So you have from 0 to 1 is 5 spaces. So 1/5 plus 1/5 plus 1/5. The next one is 3 times 2/4. So you have 4 from 0 to 1. So you have 1, 2. So 2/4 plus 2/4 plus 2/4 is going to equal 6/4. 5 times 5/8. You'll have 8 spaces from 0 to 1. And you're going to go over 5. And you have to do this 5 times. So 5/8 plus 5/8, 5 times, till you get 25 over 8, because 5 times 5 is 25. And the negative representation, I did this in red just as a different color. It's still going to be 5/8 times 5, but you have to make sure that it's negative, so you'll have negative 25 instead of a positive. Now, you're also going to look at a unit square. This unit square is partitioned into 7 tangram pieces, A through F, and G. So you're going to take a look at the square as a whole, but now you got to see what fraction gives the area of each piece. So looking at A and B are half of the square. So half of a half is going to be 1/4. A and B are both going to be 1/4. Well, now you have C. Well, C is not half of B. So it's actually going to be 1/16. And D is going to be 1/8. E is 1/16 because it's the same as C. And then F and G are both going to be 1/8 because they take up about as much space as D did as well, just a different shape. And now you're going to look at ingredients. We all use ingredients every day when we cook. You look at a recipe, it tells you how many to make for a serving of 8 or 16 or 2 or 12. So if you're trying to make a recipe that you get for 8 for 16, you would know you'd have to double it because 8 times 2 is 16. So you double everything. Well, this one, if you're working with 16 brownies and you only want to make 12, now you have to reduce the ingredients. So instead of 1/3 cup of butter, you'd use 2 1/4 teaspoons of butter, 1 cup and 2 tablespoons of chocolate instead of 3 ounces, 1/4 cup of sugar, 1/2 teaspoon of vanilla, 1 egg, 3 tablespoons, and 1.5 teaspoons of flour in order to make 12 brownies. So what I did is I just took that recipe and I cut it in thirds. Once you've divided all the ingredients by a third, you're ready to make your 12 brownies instead of 16. This module worked with fractions, adding, subtracting, multiplying, and gave you some real life examples like the recipe, because again, we all use recipes in our life. I hope I was able to kind of show you a little bit of the way to represent it pictorially and understand fractions a little bit better, because I know for me, they're kind of scary sometimes when you look at them. Have a good one.